Okay, I think I'm audible, right? So let us begin, and it's recording also. Okay, correct. Okay, today what we'll be doing is we'll be studying what is called as norms, or the length of, popularly known as length of vectors. And we'll also be seeing some other useful things like dual norms, and I'll end matrix linear algebra with leaving you with something what is called a dual norm that would link, matrix norm that would link all the components that you have studied all this while together. So before, without much ado, let us begin. So in school, what have you all this while have studied a vector's length to be? You have taken from the origin, say you have a vector of x1, x2, x3 dot 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 xn. What would be the length of the vector? So you have x, what would be mod x? So we all know for 2D or 3D, if it is x1 comma x2, the length is root over of x1 square plus x2 square, right? Isn't it? So what would be the length of an n-dimensional vector? I would, because this is a new topic, please follow me from the beginning, which will be a very easy thing to, easy thing. Please, what would be the length of this vector? X?
From x1 square plus x2 square plus dot 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 xn square.
Okay, that will be this, as you are saying. So you can have both if it was, and if the vector is complex, what would be your vectors? You would have, you would put a norm, right? If your elements are complex numbers, a plus ib, then you would put as as the norm of or mod of that numbers, right? Is this clear? This is what you have studied till now. So do you also see that if you write x transpose x, or let's write x Hermitian x, as we have discussed all this while, if for a general case, which is transpose and then taking the complex conjugate. So what will it be? As you told me, so it's x1 complement, x1 conjugate, x2 conjugate, x3 conjugate, dot dot dot, xn conjugate, and x1, x2 dot dot dot, xn, right? So what is this? What would be the inner product or the dot product that you popularly know as? It will be summation of xi bar xi, I equal to 1 to n. Do you agree this is equal to? Yes or no? And which is
Yes, sir.
also, which will be also equal to, if you write mod x square. So this is your general length. So here we will not be using a single mod anymore, because single mod can mean complex numbers. We'll use two lines, and using two lines would tell me that this is the length of a vector. Using two lines will tell me this is the length of a vector. Specifically, since you have the square of each power, this is known as a L2 norm. What is it known as? We'll see why is it called L2 norm while we go to all other norms, right? So this is Euclidean norm, all the Euclidean norm, or the distance, or the L2 norm, right? Okay, today we'll do understand what are LP norms in general, and we'll also understand different other type of norms as well. But mainly we'll deal with these norms. Okay, so what is the motivation? First, I'll be introducing what is called a So you saw, so this is a dot product, right? Dot product. So I'll be beginning with the motivation of what is the dot product of two vectors, right? So can you, so you remember from school that we used to write what would be the distance then of x plus y, the resultant vector would be the distance of the resultant vectors. If this is x, this is y, and this is x, what would be the distance of this resultant vector? So L2, this is the L2 norm, right? Norm or the distance. This from our very definition that we have written previously will be, what will it be?
X plus y Hermitian in dot x plus y.
Very good. Very good. So what will, do you recall this formula? If you open this up, you will get something like this, right? Plus y Hermitian x plus x Hermitian y, right? You'll get something like this, correct? Yes or no? I'm just breaking
Yes.
this up into this terms. So if x was real, I'm just trying to relate with your school days. If x is real or belongs to Rn, so then what will happen? Then your x plus y. So you will see all of the things that we have done, scaling and everything will be making sense today. Would become x square plus y square, since these two will become same, right? So if it is, if are real numbers, for real numbers, y bar x is equal to xy, right? If x and y are real, right? There's no meaning of conjugate. So you will have a 2x transpose y. So do you remember, recall this formula from your school days or class 11 physics? Used to write x plus y vector square as x square plus y square plus 2xy cos theta, isn't it? So,
Yes.
so this we have said is the dot product, right? So this is the very definition of the dot product. Is the two formulas matching? So you can also derive this formula by projecting y to y cos theta and y sin theta, right? And then use the Pythagoras theorem. You will get the same equation. Is this clear? Is the motivation? Yeah.
Sir, I just
Go.
joined now, so could you please give a brief introduction of what you
Yeah.
did?
So we have just started. So since you joined, so I started with something introducing what is called x Hermitian x or x transpose x. What is x transpose x? Do you agree that it is the sum of the squares of the
Yes,
elements?
I do. Yes, yes,
Yes.
yes.
So this will be, do you agree that is also equal to the length of the vector?
Yes, length of the vector.
Correct. So we are saying we are trying to relate this x transpose x to your old school days vectors, right? So in your school days, what you used to find the resultant vectors norm, you used to do something x square x plus y cos theta square plus y sin theta square, right? This is equal to your x plus
Yes.
y is norm squared.
Mhm.
Agreed? So here we have
Yes.
done the exact same thing. So x plus y norm I have written in terms of A transpose A. So the length of the vector we have seen can be written as x transpose x. Yes or no?
Yes.
So I have expanded this. I have got this thing. There is no doubt in this. This line.
Right.
And if it was real, do you agree that the Hermitian is equal to transpose?
Transpose.
This is correct. And transposes are commutative. There's no
Mm-hmm.
your complements are the same. So similarly, you have got a x plus y whole square as x square plus y square plus x transpose y. Is this match? I'm trying to say this is matching exactly to your class 11 physics uh,
Dot
definition
product.
of vectors. Exactly, of a sum of a norm of a, or a used to call length of a vector or a magnitude of a vector of a sum of vectors, right? It's exactly matching. So here today we will be dealing with this term. So we will not only deal with X transpose Y, but we'll be defining a general class called inner product. Is the motivation clear? So this need not be just dot product. So you can see in high, when you will be, if you are studying further, you will be seeing you can have multiple different type of inner products. So today we'll be mainly dealing with a few inner product, and we'll be seeing inner product as an abstract concept, right? So we'll be representing a dot product, or an inner product will be a similarity between vectors. So this is the measure of similarity between vectors. Do you agree that this is if you take dot product, you see how similar the vectors are, how similar in orientation they are. The more similar they are, there will be a lower theta, and you will have a higher dot product. Yes or no? If it is perpendicular, you will see that if they're independent, you will have a zero dot product. Is that yes or no? Correct? Are you getting it? So we'll be writing
Yes.
generalize this as this. So dot products are tell you what is the angle between the vectors. So they also tell you how similar the two vectors are. So in machine learning, you use this inner product concept everywhere. For example, in NLP, if you want to learn word embeddings, so you'll be seeing in your NLP classes very soon that in your word embeddings are learned as are optimized using this inner product. You want to maximize the similarity between similar words and minimize them between starkly different words, right? So you'll be not only here, in everywhere, in physics and everywhere, you'll be using inner products to measure similarity between two vectors, right? And vectors are everything, like everything is a vector. We will be stacking numbers that entirely becomes a vector. So this is why I was telling we'll be starting something new today. So you understood the intuition, right? So this is the similarity between two vectors. This was the story that I was telling you. So now we'll be seeing all the properties that these inner products will have, and then we'll be relating it to length of vectors. Is the map clear? So we'll be seeing the properties of the inner products, and we'll be going to and relate it with the length of the vector. Is it okay? If you have any doubt, you tell me, or I'm going to what is known as a inner product. An inner product, which I'll be representing by these angular brackets, has the following properties. So what are the properties? Let me write it down. So I have a lot of space over here. So it has a property that the similarity between two vectors of the same vector has to be greater than 0. Right? This is called positivity. So this doesn't make sense to have a negative similarity between the same person. Is it yes or no? Same object. So similar, you always think of similarity between objects. Now you have to understand in the abstract space. So norms are defined on a vector space, right? We have understood what a vector space is. So now we are defining operations of similarity on the vector space. Why is everyone quiet? Is it not clear? I have not defined anything yet. Is the motivation clear? So 2 would be what is known as a homogeneity. So this will be, if you scale a vector, what would you expect? That the inner product would be scaled, right? Always try to relate it with the initial example that we have of X transpose Y. If you are able to relate it with the initial example of X transpose Y, you will be done. Number 3 would be what is called additivity. This is homogeneity. So if you are adding two vectors, you will be left with. So please see the axioms, and then we'll be implementing using these axioms. And number 4 would be what is called a Hermitian property. That we have already seen, right? Y Hermitian X is equal to this. You have already seen. X Hermitian Y is nothing but the conjugate of X Hermitian Y. Remember this. So this is known as the Hermitian property. This have to be considered for complex and real matrices. Are the axioms clear what I meant? Or you want some specific clarification, some specific motivation? Tell me. Because once we go into the math, you will not be able to come back here. Anyone? Any question? Am I audible anyways?
Yes, sir.
Okay. So if it is not, if it's clear, can I proceed?
Yes.
So let's use these properties to prove one thing, that is you popularly know as the Cauchy-Schwarz inequality or the Cauchy-Schwarz inequality. What is the Cauchy-Schwarz inequality? I think you must have known this inequality, right? So length of a vector y comma x, the norms of these two vectors is greater than x y cos theta. Yes or no? Or cos
Yes.
theta is less than equal to 1. So you already, this is a known equation, right? Everybody knows this. Very good. Let's see. Let's prove the Cauchy-Schwarz inequality for this general class of inner products. So we will not be proving it for only transpose and dot products, but we'll be proving for abstract spaces. So it is defined as a similarity. So inner products is a similarity. Remember this always. Similarity measure on any abstract abstract vector space, and must satisfy these properties. If and only if they satisfy these properties, it's a norm on the space. So let's define the Cauchy-Schwarz inequality for a general class of matrices, general class of norms, inner products. So here I have given you a hint. So take V is equal to the inner product of y into x minus the inner product of x and y into y. So this is the hint. Don't think like this is found by hit and trial. So don't think about how we got it, because that is just by calculating, rearranging terms, we'll be getting it. But if we take this, do you agree V inner product with V is greater than 0? Yes or no? You agree, right?
Yes.
Because from the definition of positivity, right? See, this is how you need to do abstract proofs. I'll just show you how to do abstract proofs. See, I'll not be using dot products anywhere, but we'll be ending up with the results that we want. So what is V transpose V then? Y x minus x y, and you'll be having y x minus x y, right? Before we go on to solve this, to decrease the notation and hodgepodge, what will I do? I'll just show you what is a sum of two. Yeah, I'll show you the sum of A plus B inner product with C plus D. Can you tell me what will it be? How will I expand this? First, what property will I use? Additivity, yes or no? If I use additivity,
Yes.
what will I get? What will I get? A C plus D plus.
Plus B, C plus D.
Very good. And then what will I use? Now I don't know any property. I have to use only those properties which are given to me in the 4 properties. So I will be using Hermitian property, yes or no?
Mhm.
So Hermitian property will make it C plus D, right? C plus D comma A plus C plus D comma B, yes or no?
Yes. Yes.
Now you can use additivity. Next steps, I will not write the names of the property. So you can use CA and DA plus CB DB, correct or no?
Mhm.
There's no, I'm using additivity again. And you know the sum of two complex numbers is conjugate of two complex numbers is the sum of their conjugates. This is very simple, right, to prove. It's nothing. Yes or no?
Yes.
So recall, this is if it's a plus ib, this is c plus id. So you have a plus c, b plus d. And if you take conjugate, you get a negative. And same is going to happen here. The conjugates are a minus ib, c minus id. Very good. So what will this be? Again, you use the Hermitian property. Will you get AC, comma, a plus AD plus BC plus BD? Yes or no?
Yes.
So it is going to be a normal product or not? It's like exactly like this or not? So you have just
Yes.
taken multiplication of AC, AD, just doing a cross multiplication sort of a thing. Is it yes or no? So these cross multiplications will be allowed in the case of inner products. So we'll be using the cross multiplication result that we got just now and show the results. So what will this be now? Tell me. So from the cross multiplication at the end, what will I get? What will I get? This and this, yes or no? X comma X, then minus X comma XYY minus XYY YYX. Once I write it down, I'll wait and then you will tell me if it is okay. Plus XXY comma XX Y. Is it okay? Everyone? What I've done is I've taken this term as A, this as B, this as C, and this as D. Is my expansion clear or correct? What happened?
So why
Is
did
it
you
not?
write XX at the end?
Which one? This one.
To the last term. Yes.
I wrote na XX. Oh, okay.
I
Just
mean,
sorry.
why?
It will be XY. Sorry. Exactly. This is why I'm telling you to follow. Others are it's okay. I just have print writing mistake. Exactly correct. Others are it's okay, right? Rest terms are okay.
Yes, sir.
Yes.
Good. So what will you get from the first term? What will I use? You agree that this is a number? Complex or real something? Because inner products will give you, by definition, it will keep converting two vectors into a similarity score. Yes or no? Real bar complex? We don't know yet. Whatever, it depends upon the type of vectors. Right?
Hmm.
Good. So what will it be? Tell me. So I can bring this number out or not? By the property of homogeneity? This property? What am I putting? This property I can use?
Yes.
And we can also use the fourth property in tandem. And then what will I get? Can you tell me if you have understood? If I use the fourth property also, 4 and 2 together, 4 and 2 together, what will I get? So would you agree I will get YY norm squared XX? If you agree, you tell me, or I'll show you with the green color here. Why will I get this? Let's see the green color. I don't want to skip steps. So you will get y x comma y x. Yes or no? As you have told me rightly. First step. Second step, what will I do to remove this y? This is also called the sesquilinear property. So I have written it down somewhere here. Yes. Sesquilinear property. So it's linear in the first component and semi-linear or conjugate linear in the second component. Right? So how do I prove this? Can you tell me? Instead of proving it for a long written statement, I want to write it for this small xyc is equal to c complement xy. How do I do this?
So we can first take the complement and take C outside, then again take
Good.
complement.
So I will use the Hermitian property to make this cy comma x, and then I will use the homogeneous property to take c outside as what is your name? Because it's not Saptarshi, right?
Yes, sir.
Okay. Don't call me, sorry, you can call me Dada.
Okay.
And then is this okay? So again, you will use the Hermitian property. So you will have c bar x comma y. Correct? This is called sesquilinear, means 1.5 linear. It's is the meaning. Exact. I think it's a Latin meaning. Sesqui means 1.5. Right? So do you get the now what will this be? So you will be y bar. So what is CC complement? It's the norm square. Do you agree?
Yes.
Any complex number and its conjugate, if you take product, you will get the square of their real and imaginary part. That's what I've written. Next, first term I have got.
Sir,
Yeah.
so can you just repeat that property what you just said that?
Sesquilinear property.
Mm-hmm.
So first, if there is a constant in the beginning, it will just come out by homogeneity. Yes or no?
Yes.
If the constant is in the second component, if this is in the second component, what I
Then it
did
will be
is
conjugate.
exactly. So it's not exactly linear both ways. It's linear in one way and half linear in the other component. Do you get the
Mm-hmm.
philosophy of this? That's why it's
Mandam.
named. Yeah. That's why it's called 1.5 linear. They're kind of linear, to be exact. Okay. So first term I got, which term is easier to get again? The last term, right? If I get the last term is also simpler. What is the last term will be? The last term is equal to the norm square of similarly, right?
Yes.
Xy square yy, right? What would be the other terms be? What would the other terms be? This term. So I have done this term and this term. So second term will be, do you agree it will be y xy complement into xy? Yes or no?
Yes.
So I'll first take yy out, then take the complement, right?
Yes.
If I take the this out, I will be left with y, and then I will be taking a complement and I will be putting this term in front and then putting this out. So this term will become again y xy whole square, right?
Yes.
Same will be with this. Do you agree? Or yx will it become? Just check once. So it will become, what will this become? This will become xy yy bar and you will have xy complement? Yes or no? Just check once. Is it correct? Yes, it is correct. Yes or no? Just see, first I'll take xy out and then I'll put y in front and then I will get yx or xy complement. Yes or no? So I'll have two
Yes.
terms. Yeah, this is not that difficult to see. So I'll have two terms as, and do you see that yy complement is nothing but conjugate of that is nothing but yy? Do you agree? You can just shift y without even noticing and conjugate will disappear. Yes or no? Yy conjugate will be nothing but yy. Yes or no? If you have not understood, tell me. No problem. So you will be left with yy squared xx greater than xy squared yy. Is it okay? Is this step clear?
Yes.
Now what will I do? It is clear. So I will cancel one of these. I will cancel this and I'll be left with yy conjugate. Yes or no? What is the norm square of yy? It's the conjugate of yy into conjugate into yy. Yes or no? So I'll be left with
Yes.
xy whole square less than equal to yy conjugate into xx. So again, a yy conjugate is nothing but yy or not? Right? I think is this yy conjugate being yy not clear? So a complement means what? Let me write one a with red and one with green. It means a, yes or no? Write the Hermitian property.
Yes.
Good. So we have derived the well-known Cauchy-Schwarz equation that you have already known for ages using just properties or axioms defined. So these have to be the property of similarity when you are actually designing any norm for any vector space. Okay, so tomorrow or not tomorrow or Saturday, we'll be seeing what is called as a Holder's inequality. But for the time being, we'll be using the Holder's inequality very frequently. So please bear with me. So Holder's inequality says that it is the general form of the Cauchy-Schwarz inequality, right? Your Cauchy-Schwarz inequality is what? X Hermitian y for the special case where the inner product is defined by right? If I define the inner product, define the inner product as X Hermitian y, your Cauchy-Schwarz inequality says that this is less than equal to, yes or no? This is what it says. Or your more popular form, as if I put directly, is squared, squared, squared. Right or wrong? Which I have already derived here. This equation. So in place of x, I will get xx Hermitian, that is mod of norm of x squared, y Hermitian, y Hermitian y, that is norm of y squared, and I will just put this over here. Is this clear? You have to relate these two terms very fast. I mean y transpose y as the length of y. You can understand, right? This one we have shown in the beginning. So y transpose y is the product of the individual components. So that is nothing but y1 squared plus y2 squared plus yn squared. So that is the length. Just remember this link very always, then only you will not be lost. So this is the definition, but since I told you today we'll be dealing with not only Euclidean spaces, but any general spaces. So this is something known as the, so any dot product is upper bounded by a P norm and a Q norm, such that 1 by P plus 1 by Q is equal to 1 and P comma Q is greater than 1. We'll see. This is known as the Holder's inequality. We'll be seeing this in more detail once I tell you about the dual spaces, but don't worry about that. So this is the, do you agree this is the generalized Cauchy-Schwarz inequality sort of? So if I put P equal to Q equal to 2, is it okay? P equal to Q equal to 2. Will I get back the equation that I derived just now? Yes or no?
Yes.
Okay. So we'll be seeing this proof next day because that deals with Jensen's inequality and so on. But these are known as dual spaces. We'll be seeing that today. But anyways, we'll start with inner products and norms. They are the same. They are the same thing. The two sides of the same coin. So once you have defined an inner product, it is a comparison between two vectors, right? Inner products. What have we seen as inner products to be? Inner products are comparison between vectors. Norm is defined as the length of the vector. So this is the norm, right? So we have done this many a times. We have normalized by the length and so on, but we'll be this. See, the norm also has the same properties. Do you remember? Give me an intuitive measure of a norm. Can you give me an intuitive or which you already know without seeing the definition? Length of a vector I have told you already. So for length of a vector, let's define the properties of the norm from the things that you already know. Please tell me some properties and it will be interactive instead of just telling the axioms directly. It will be better. What would be the property of a length of any vector? What would be the properties? What would be the first property of a length? Property 1 of length. Length is greater than 0 or not? Length is
yes.
always, length is positive. Also, do you remember length of two vectors is less than equal to the sum of their lengths? Yes or no? It's according to the triangle rule. One triangle. Yes or no? The length of x, the length of this side, length of any side C. If you have A, B, C, A is always less than B plus C. Yes or no? Correct?
Yes.
This is your class 3 definition. That is how you define a triangle. That a a triangle has the sum of two sides greater than equal to the third side. And what is the third one? So if you scale a length, so 1 centimeter into 5 will be 5 centimeter or not? So you can scale a vector by any length. This is the third property. So now it is clear. Now tell me what will be the property of a norm? One after the other, if you have understood. Am I audible? What would be the properties of a norm if you? So tell me what would be the properties of a norm? So see, so you have said length is positive, so the norm will be positive. Length is positive, so norm is a length on a vector. Only 0 when x is equal to 0. So length of a dot is 0, correct? Similarly, homogeneity will tell me scaling a vector would just scale the norm of the vector, correct or wrong? And the triangle inequality, the norm of the sum of the vectors is less than the norm of the individual components. Is it clear from the Euclidean sense why I have defined these as the properties of norms? So what am I trying to do? I am trying to generalize the Euclidean sense of distance into a general class of distance that can be used for multiple types. So if you see in cryptography and everything, so these fields can be anything. It can be modulo fields. It can be anything, and you can define norms accordingly for them. So it need not be exactly x transpose y. We are trying to, that's why, learn a general form. Okay, since you have understood. So a vector space can be equipped with a norm is called a inner product space. So generally what we'll be dealing with today are called inner product spaces. So a vector space that has a norm is called an inner product space. So let's see. We will define a norm by an inner product. So this is a question. I will show you the relation. This will show you the relation between inner product and norm. Not only it is not a general relation, but a specific relation. So norms can be anything. It need not be defined with an inner product, but you can always define it with an inner product. So I will say the inner product between vector is the norm of the vector. So tell me, how will I prove this? So first statement 1 will be norm of x has to be greater than 0. So this is a very interesting class. Tell me, using all you have to do is use the information given to you to prove these. So you have to do something called as a logic. There's no maths here. So you have to use what is given and just tell me how will you formulate to show this. So x is greater than 0. What will you tell me? What knowledge will I have? How will I show x is greater than equal to 0? If you are not following, tell me. So how have I defined more norm of x? Norm of x is x comma x to the power half. Yes or no? This is for my inner product norm. So what do you remember that from the, what is the similarity between the same vector? It's always positive or not? From the definition of inner products. Do you agree? If you do not agree to this, we'll have to go back. Any doubt? So when people are quiet, I understand there's doubt. Please tell me what doubt you have. Hello?
It's clear now.
Yeah. Then if it is clear, please help me with the second part. How will I do? Because this is what I'll be doing throughout the class today. I'll be helping you to understand how to do proofs in mathematics and in computer science. In computer science also, you need to do proofs similarly. You'll be seeing as you pursue higher studies. Tell me, what will I do in AX? What will I do? How will I prove that this is equal to norm of
So we
A?
can
Yeah,
write it as
yeah,
inner product of x and x
very
to the
good.
power half,
Yeah, this is
and
equal
then
to,
we
use the
can take both
homogeneity.
the yes,
So you'll take all the A's outside, you will
a
get A star.
a
Oh, again, I'm mixing A conjugate A
oh, yes.
into x comma x. So you will get a square half x half. Very good. So you have understood. Now third part is a bit tricky, but we'll start off. So first step, someone else, can you tell me first step, what will I do with the third part? That's the proving the triangle inequality. And then I will tell you the technicality to prove that. Hussein, can you tell me what step, what will I do? So I want to prove x plus y is less than mod x plus mod y. How will I prove this? First step, what will I do? I will start from the LHS or not? I'll start from the LHS. Let's start the easiest way. I'll start from the LHS. I'll write x plus y comma x plus y, right? This is what is norm of xy to the, let's use squared for the time being, right? No problem if I use a square, right? This is true. The LHS, you are happy with the LHS?
Yes.
So now what will I do? Please, someone else. Brahmojit is not interacting. Tell me. So this I will convert to a AB form, right? So A, B, C, D, as we have already always had. So this will be X, X plus Y, Y plus X, Y plus Y, X. Is this right? We have already shown this will be the case when we are when we are taking the distributive property over to sums. So what is it equal to? What is this? Norm of x square or not? No, 2. Correct?
Yes.
This is equal to norm of y square. By definition, we have defined the norm to be the angular brackets to the power half. So y will be square of the norm. So what will be this is the major question. Can't anyone tell me what is this term going to be? Plus so it's xy plus. So do you see that this term is going to be
xy plus xx plus
no
yy
x,
plus ix.
that will become lengthy. So xy plus xy complement, can I write?
Yes.
So this is what? Real part of xy, right? A plus A conjugate is 2 times real part of A. Yes or no?
Yes.
Because A is, say, A plus IB, A bar is A minus IB. So this is equal to 2A. So this is 2 times real of xy. Now what technicality will I use? Now you tell me. If you have understood all the while, I'm giving you a hint. You have to end up using Cauchy-Schwarz, because that will give me a whole square form. Yes or no? But how will I go about using the Cauchy-Schwarz inequality? So I have already seen the Cauchy-Schwarz inequality was. Let me just write the Cauchy-Schwarz inequality down. X comma y whole square is equal to, what did I write? Xx yy. Yeah. So what will I do to this? How will I convert to xy squared sort of a thing? Any idea? So do you agree real of A is less than equal to norm of A? Yes or no? Real part of A has to be, so real part is just A. So if your A is some x plus iy, so this is x square plus y square. Yes or no? And this is just x, right? It's sum of two
Yes.
squares. So sum of two squares is always greater than the single square. Yes or no? Others? Good. So I'll replace this as. Why is everyone falling silent? And I will get a. Do you agree? Because I'm increasing the right hand side, so my equality will become a inequality. Yes or no? So next, I'll replace this as x to the power half, y to the power half. Am I done now? Is this equal to Is it okay? So I'm going to use the Cauchy-Schwarz inequality here. Good. So I'll be left with x plus y. The norm of the sum of two vectors is less than equal to the individual norms. Understood? Can I proceed to what is known as some other general norms so that you can understand better? Okay, so let's see. So first I'll be showing what is known as a Euclidean norm. So let us define something called as norm balls. So you'll just see the space of what does it mean. So you will be able to relate a lot of things. See, so a Euclidean norm, do you agree that mod of x squared is equal to x1 squared plus x2 squared plus x3 squared and so on, xn squared?
Yes, sir.
So do you see, if you have said for this section that I'm doing the drawing on, I am going to consider x to be two-dimensional. Okay. Let's consider. So how will you convert a two-dimensional thing into a three-dimensional thing? You'll just close your eyes and think the volume, it becomes
Other
a
dimension
volume.
is 0.
Yeah, circles will become balls will become a hyperball, hypercube, and so on. So let's see. So I am saying I am going to define a norm ball. So let's define a norm ball as less than equal to. So what will it be? X squared plus, let's write x1 squared plus x2 squared less than equal to 1. Is this
1.
this is equal to what I'm saying? So what is this equation of x1 squared plus x2 squared less than 1 square? Do you agree this is the equation of a circle?
Yes, sir.
So your normal Euclidean distance are balls from the origin. They are circular balls that expand. So that's why there is a very, very good relation between, we have shown using there's a between polar and Cartesian coordinates, right? So polar coordinates can be converted to Cartesian coordinates and vice versa by just taking the squares and taking the length and theta, right? So that's why you have all these properties that hold for this norm ball. So now tell me, now is what I've told you previously are called LP norms or norms with any p greater than equal to 1. So how will you define p greater than equal to 1? Norms with p greater than equal to 1. How do you define x2? First tell me. You define this as summation of xi squared I equal to 1 to n to the power half. Yes or no?
Yes.
So what will be your LP norm then?
To the power p whole to the power 1 by p.
Very good. So why are we doing LP spaces? Because they are helpful in probability as well. So you can show using LP spaces convergences of sequences, the convergence of random variables. If you study more statistics and linear algebra, you'll understand why it is important. There you'll be just doing the convergence of the random variables, and it will be depending on these norms. So this would be a P norm. So tell me what would be a one norm? So L1 norm ball. Let's consider
Sigma 1 to
two-dimensional.
n xi.
Very good. Mod of xi, right?
Yes.
So if I'm taking x to be x1 comma x2, or let's write y here to be just not mix up notations, so overload them. So I'll write y. It will be mod y plus mod y2. Correct? Yes or no?
Yes.
Right? So if I define a space or a set such that it is all those vectors such that norm of x is less than 1, what will it mean? it will mean y1 plus y2 is less than 1, right? Correct? So if this is less than 1, what does it mean? What are the sum of the equations that you will have? y1, y2. If y1 greater than 0, y2 greater than 0, you will have y1 plus y2 less than equal to 1. Do you agree this is this line?
Yes.
Everything here. So what happens if you take mod? Remember your graph plotting. So if you take a mod on the x-axis and take a mod on the y-axis, they become mirror images across the x and y-axes. Right? You have taken a norm on both axes, so you will get all these lines. Yes or no? You can check. How will you check? Say if y1 is less than 0. So what will you have? Minus y1 plus y2 less than equal to 1. Right? Correct?
Yes.
So that will, what line will it be? This will be this line, right? If this is y1, this is y2. Check if minus y1 plus y2 is equal to, so for example, minus 0.5, comma 0.5. This will fall on this line, right? So minus 0.5 and 0.5, and that sum will be equal to 1. Yes. So any doubt, Romojit? You are unmuted. You want to ask something?
No, Dada.
It is clear.
Yes.
Okay. So what will be your L infinity norm? So L infinity norm is a bit tricky. So this is a very useful norm in your computer science approaches. So you may define L infinity norm for to be maximum of x1, x2, xn. Can you tell me why is this true? Can a brief intuition as L infinity norm is this? Why? Your L infinity norm is this because let us write the definition of a norm. P norm is, what is your P norm to the power P? Summation of xi to the power P, yes or no? I equal to 1 to n. Just now you all told me this. So if I take the maximum common, so x max I'm going to take common. So what will I be left with? Xi by x max. I is not equal to x max. Do you agree? I'll get something like this or not?
Yes, sir.
Very good.
Sir, can you repeat this? Can you repeat this? Didn't get it.
So from this statement, so you have a vector has 10, say 10 components, x1, x2, x10, right?
Yes.
Say x5 is maximum.
Yes.
Max. So if I divide by the x5 throughout, right?
Yes.
So what will I have? X1 by x5 plus x2
Yes,
by
I will
x.
have.
Yes. So I have taken x5 common outside. And I have summed all the terms except all terms except
Except 5.
the far
X5.
largest term. Yes, largest term. And kept that outside. So if limit p tends to infinity, what will happen?
This will be 0.
Exactly. This term, what you have over here. So you will have
So
something
it will
like this.
remain to be xp whole to the.
Something like this. So this all these terms will go to 0, right?
Yes. And yeah, so one will remain or x I to the power p will remain.
1 into x to the power p will remain.
Yes, yes, yes.
So that is, so do you see that your limit p tends to infinity, or the infinity norm is the norm of x max? There is some technicality which I have left behind, but generally speaking, you can take the p norm to be infinity and show that this is the case, right?
Sir, what did this mean actually?
So it means that as you go higher and higher, it is useful to take the largest component. So if you have a very large p norm, so do you see the max of, what is the graph like of max? Say max of x1 norm and x2 norm. What does it mean? What is this graph look like? If you can visualize this graph, you will be done. So x1 and x2. How is the graph going to look like? So let's say a norm ball S infinity as where the more norm of y infinity, we are going to keep all the y's where the norm of y infinity is equal to 1. What does it mean? So the maximum component in this case will be 1, right? Yes or no?
Yeah.
So I am saying the maximum of these two will be 1 or not. Hussein, are you understanding?
Yes, sir.
Did you understand the maximum will be 1? So if you have a line y equal to x, correct? Yes or no?
Yes.
Anything above this, somewhere here, your x comma 1 over here, what will it be? The max of x comma y over here, say a point here or a point over here, will all be x2 or not? Above y equal to x line,
Yes, there will be
it will
x2.
be correct. And anything below the x to y equal to
Will be
x line will
x1.
be x1. So if you put norm equal to 1, you will only be left with these points. Do you agree?
No.
Yes or no? So wherever the maximum component is 1. So you will be, if you are putting less than sign, so you will be having this entire box. So from this perpendicular, where the initial L1 norm was a perpendicular norm, right? 45 degrees with the y-axis, 135 degrees with this y-axis, and 45 degree with the square. This ended up becoming slowly converted to a maximum norm. So slowly this rectangle will shift and it will end at a place where it will only give you the maximum norm, right? Okay. So there is something also called the L0 norm, just for your information. This is number of non-zero components. This is not a norm exactly, but people use it for computer science purposes and so on. So with that, we'll have understood what norms generally are and what different type of norm balls are. So to properly appreciate norms, we need to understand what are called dual spaces. So and their associated norms. So this is the major part of the of any norm. So once if you have this is clear to you, we'll move to dual norms. So dual norms would be, so slowly we'll be building this up. Say you have a vector x, right? And if you define a set of all y's, right, such that, or all f's functions which are linear, that maps x to a real number, this set is called the dual space, right? A set of all functions such that it maps vectors to a linear functional to that maps you to another vector space altogether. So it is a set of all functions that will take a vector and give you a real number. So can you tell me what is the easiest way to convert a vector to a real number? So you have a vector x, x is x1, x2, dot, 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 xn. How can you define a function
Multiplying it
on?
with a transpose.
Correct. So if I have a for vectors, a function is nothing but y transpose.
Hermitian.
This is the function. Yes. This is your function of x. This is your function. For any vector, you can define all set of functions using this as the parameters of the function. Right? So if you have y equal
Yes.
to y1, y2, dot, 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 yn. So what will you have? Fx as, let's not write y as y1. Y becomes a more of an algebraic, what is it called? A variable. Let's write alphas that we have written all the while. So alpha 1 x1 plus alpha 2 x2. Do you agree? Alpha n xn. This is going to be a, this is a linear function or not?
Yes.
So it's a linear combination of all the xi's. So it's a linear function.
Yes.
It will give you all the set of all linear functions using xy's. There's no linear function left that you cannot get using these linear combinations. So your this y can be written, these alphas can be stacked as y Hermitian x. So this is the intuition of dual space. All the functions. What is it? It's a set of all the functions that map your vector x to some linear fundamental functionals. So it's a set of more linear functions that can be used on a vector space, right? For on a vector space, you can use all these linear functions. So you can, for Rn only will be your dual space. Do you agree? You can use all Rn as the dual space and so on, which is may not be always the truth. So dual space calculation. So your dual space will be a space of all these linear functionals. So these will be vectors in themselves, yes or no? Alpha 1, alpha 2, dot, dot, alpha n, right? And you will have a set of all these vectors.
Yes.
The beta 1, beta n, and I am saying that these will form a vector space. Right? This is known as a dual space. So all this set of vectors will have all the properties that we have defined for a vector space. So we are going to define the norm. So what would be the norm of this vector space for a particular value? So how will I define the norm? So norm is the length, right? Sort of the length that we have defined. Yes or no? Correct?
Yes.
So if I
Yes,
can sort, yes, it is the length. So I will try to see which function that I already have has the best length, sort of a best length. Let's see. So for any norm, say you have a norm, this necessarily need not be a norm, just needs to be a pre-norm. So why we are doing dual spaces? Because the dual space norms are well defined. So in your space, if your norm is not defined, there are spaces where norm is not defined. Your dual space norm will always exist. I'll show you why. So this is why dual spaces are very important. So f dot need not be a norm. Means just needs to have fx greater than 0, right? And f of ax equal to afx, right? These two properties must hold. So what are these two properties? Positivity and homogeneity, right? So you tell me, if these two properties hold, which property is missing here? Which is the property is missing? Exactly. So x plus y less than equal to need not be less than equal to x plus xy. So this is what it is more general. So f can be more general, and yet you will get a norm in your dual space. We'll show why. So a norm will be defined on this dual space as the supremum. We'll be showing geometrically, so don't worry. Let's first understand the definition, and then I'll go and show you what does it mean geometrically. So don't worry about the geometry yet. So your dual norm is known as, so I'll be writing dual, f dual. So your original norm or the primal norm is f, right? Primal pre-norm is f. And your dual norm we will write as f dual. So that is defined as, for a particular value of y, right? It will be for a particular value of y, and we are saying set of all functionals will be treating for that y. Yes or no? So how do you, on what do you define a norm? You define a norm on a vector, right? Like this, you define a norm.
Yes.
So I am saying on this, I can define a set of functions, right? I am on this, I am defining a set of functions like x Hermitian y. Yes or no? Just on y.
Yes.
Y, I am defining a set of functions x Hermitian y, and I want to find what would be the best sort of a length for this. Do you get it? So how will I get? It will be the max of all functions such that the norm is equal to 1. So slowly seep this in. So max of all x, these are functions. Remember, these x are functions that I impose on y. 1, just put a norm here, y Hermitian x. Is this understandable? So I am seeing for which function is my inner product getting maximized. That is known as the dual norm. For which function my dual norm, my inner product. So if you are not clear, you just ask for which function my inner product is maximized. Tell me for which. So did you understand? So for which product I'm trying to maximize the inner product such that the function has a unit prenorm. Yes or no? So there has to be a constraint. Why has to be there a constraint? Can you tell me? Can anyone tell me? If there was no constraint, what would have happened? Very simple. Tell me. So if there was no constraint, I could have scaled x as some alpha x, and I could have put alpha to be infinity. Then only this will be trivially infinity or not. So you have two vectors. Say these two vectors maximize your inner product. So I've drawn the two vectors, yet not appeared on the screen. Say in L2, these are the two vectors that you have. One is this vector and one is this vector. This is your x, this is your y. Right? If I don't constrain x, if I do something like max of x, y Hermitian x, what will this be? Anyone tell me? Over all x? Will I not make this very large? I can maximize x as much as I want. So I will make it alpha x. So it will be norm of x square into alpha, and I'll put alpha to infinity. So this will become automatically infinity without giving me any proper norm. Do you agree? For everything you will get infinity. If it is not okay, tell me which part is not okay. I'll be waiting for 5 seconds. Okay, so it's okay. Good. So we were defining, we are putting a constraint on x is equal to 1. The norm has to be equal to 1. And max of this is equal to y Hermitian m of this. So I'm seeing which of the functions maximizes my inner product. So what is the maximum value I'm getting from the function? This is what I'm trying to see, right? What is the maximum value I'm getting from the function? Maximum value from all functions, all linear functions, right? This is the intuition. So do you agree? I can also write this as max of x not equal to 0, y Hermitian x by fx. Do you agree? Can I write this?
Yes, sir.
Why?
So it is the same thing that you wrote earlier, right?
So I have written initially I have not, I have written sentence, this one, this box that I have on the top where I have an infinity. What have I changed from that statement?
So could you please repeat the
Initially
last two
the,
seconds? It got cracked, the voice. After I
yeah,
said
yeah.
that you wrote the
So
same thing.
till now you have understood that you can increase the norm to infinity if you don't have a constant, right?
Yes, yes.
So if I if I want to use all vectors, I will just divide by the prenorm. So you see f of x by fx. F is a prenorm. What fx is a number or not? This is a number. So by homogeneity, what will happen? Number will move out or not? Property
Yes.
of homogeneity of any norms. So I will have 1 by fx into fx, which is equal to 1. Yes or no?
Yes.
Right? So for any x, I can, or for any x, I can do this now. Instead of just doing for all those x on the norm ball. So why I was describing the norm ball to you? Because on the norm ball, unit norm ball, the length is 1. Yes or no?
Yes.
So we had said it is equal to 1 on the norm ball. That's why I had been describing the norm ball to you. Everything is being done in a serial floor order. So that's why if I divide by, tell me where have we done this? So if I divide a vector by its norm, it gives me the unit vector or not,
Yes.
right? So it's exactly that. So you see it's an abstract unit vector that you're getting with respect to f norm. Yes or no? F is a pre-norm, you're getting a unit vector with respect to the f norm. Yes? Right? The
Yes.
length of this vector is 1. Okay, now what I told you, why do we need this? Because normally normal norms do not have the nicest of properties, right? I said they can be bad, like pre-norms we have shown here. They may not have the triangle inequality, which is very important in most things we'll be seeing today. So the dual norm will be shown to have all these properties. So what will I do? Can you tell me to show this? So to show that the dual norm is a norm. So what will I do? The first step, what will I show? Positivity, right? So f dual of y is defined as max of f of x equal to 1, y Hermitian x. Yes or no? Right?
Yes.
So do you agree this is greater than or equal to any y Hermitian x? Because I'm taking max over all
Yes.
x's here. Yes. Such that f of x is
Greater than
equal to
equal.
1. Greater than equal to whatever. Max is taken, so it is correct. So do you agree that this is the greater than 0? I can always make a matrix, make a number greater than 0 because it will be only 0 if y equal to 0 or y perpendicular to x. Then 0 holds. 0 holds only this. So I can always get a y which is say at 5-degree angle. So it will, the dot product will not be 0. Do you agree? Yes or no?
Mm.
X comma y, if you do a dot product between 5-degree with 5-degree angle between them, they will not be 0. You can always get one vector. Your y itself will be one vector, right? Where you will get mod y square, right? So your f dual of y will be greater than 0. 0 if and only if y equal to 0. Agreed? So positivity is true. Number 2 will be this. You will tell me this has no technicality. Homogeneity. Homogeneity, how will I prove? That is f dual of ay. How will I write f dual of ay? I'll write. Tell me. I'm trying to make you practice this. Right? Fx is equal to 1. Ay Hermitian x Yes or no?
Yes.
So what is this? A will move out or not?
Hmm.
A is a constant. So I will get. Agreed? This is your norm, dual norm of
Yes.
y. Good. So we have proved the homogeneity also. Number 3 is the triangle inequality. See, F does not follow triangle inequality, but F dual will. How will I prove it? Let's start. F of say x plus y dual, right? So here is what we'll start with. My goal is to prove x plus y less than equal to. This is what my goal is. Yes or no? Or rather, if I write in terms of dual, right? This is what I want to prove. Tell me, how will I prove this? So this is equal to what? Max of some z Hermitian. Let us write x and y I have already selected. Yes or no? I wrote the definition. Is the definition clear? So whatever parameter you will have, you will optimize that parameter. If you want to remember it in some way for today's class before you revise and understand the entire concept by seeing the video again, just recall whatever is the parameter, you will keep the parameter and you'll be trying to optimize over another variable whose norm has to be 1, right? Is this good to remember from now onwards? Whatever is the parameter of the dual norm, you will keep the dual norm and you will take the dot product with an optimizing parameter which you want to take the max over. Is it okay? Okay. So what will it be? Do you agree that a plus b is less than a plus b for numbers? Yes or no? Because a is greater than mod a. Similarly, b is greater than mod b, right? So therefore, a plus b is less than equal to a plus b. Yes or no? Similarly, you can show minus a is less than equal to mod a, minus b is less than equal to mod b, minus of a plus b is less than equal to a plus b. Yes or no? And link this to a plus b is less than. I'll give you an example. Say 5 and minus 3. So if you add, what will you have on the left side? 2. But on the right side, you will have 5 plus 3 equal to 8. Is it okay? Is it clear? Why am I not
Yes.
audible or what? Okay, so how will I write this? Can you tell me max of f of x, f of z equal to 1, z Hermitian x plus z Hermitian y? Yes or no? Again, I can also
Yes.
show this you will tell me. How will I show this? Just writing the statement down for your benefit. So this is f dual of x plus f dual of y. So will be, this is proved at the end. Okay, so let's see how to prove it. Oh, we are almost done. Only 2-3 things are left. Okay, so how to prove that max of a plus b, right? So I'll write fx plus gx over x is less than equal to max of x fx plus max of x gx. Is it intuitively clear, this one? I think this is intuitively clear, right? There's no problem with this, the intuition of this. So for a particular x, you can make a function to some optimal value, the sum of two functions. But if you can maximize both of them and then take the sum, of course, it will be a superset, right? Yes or no? Is the intuition clear? Prove, I can show you. Maths may not always make
Yes.
sense, but now tell me, how will I prove this? So I will prove it in the same way, right? So do you agree f of x is greater, lesser than, equal to max of f of x? Right?
Yes.
Similarly, g of x is less than, equal to max of g of x. By definition of max, we are finding the max of the function. So say a function is like this. So I will be finding the max over here. For all values of x, it will always be lesser than the function. So if I add these two, what will I get? F of x plus g of x is less than, equal to max of f of x plus g of x. Right? So now whatever we proved, how will I prove it? What will I do? So I have told I have to bring a max on the left side. Why will I be able to bring the max? Do you agree that the right side is independent of x? True for all values of x, that is true for all x. Yes or no? Because if you're maxing out an equation, you're marginalizing, taking the max value. Max is a single number, right? Max of a function is a constant. Right? So if it is a constant, I can take the max on left side since it is true for all x. Yes or no? If it is true for all x, it's also true for the maximum that is on the left side. Yes or no? This is true for all x. All x, therefore true for the maximum as well. Is it clear? So is the proof clear? Can we proceed?
Yes.
Others? Okay. So now I'll be showing you the interpretation of this. So interpretation of this would mean I'll be showing you the dual norm of this of the L2 norm is itself. And I will also be showing you a non-trivial case where I will be showing you the dual norm of a one norm, which will be the infinity norm. And then I'll be showing you something called as a generalized Cauchy-Schwarz, which will automatically more or less complete norms. Okay, so this is very simple. Can anyone tell me how will I prove that the dual norm of x is the self-dual? So will be only for this part consider geometry only. Right? So your x dual is, do you agree? It is the max of all y equal to 1 y transpose x or y Hermitian x. Yes or no? Such that the dual norm, the norm of y is equal to 1. Right? Is this okay? I told you whoever norm you want to find, you put it here and maximize over the other. So what does it say? Where will you get it? So where is this quantity? So you have to find the set over which you want to maximize. So what is the set? I've already discussed this. So let's take y as y1 comma y2. So your y norm less than equal to 1, what does it mean? All of you said very yes, yes, yes when I explained that. Y2, y1. Tell me.
It will be a circle.
Circle. because this is equal to y1 square plus y2 square root over equal to 1. Good. So now you tell me you have any x. Say you have this x, right? Agreed? And so what is the objective? Now you see everything will fall into place. Pay attention. So these are the y's, different y's you have, right? Over which you have to take the dot product. Do you agree? y1, y2, y3, y4, and finally take max of y transpose x. Consider real for the time being. Is it okay? Right?
Yes.
So tell me which y will give me the maximum. So do you see that y transpose x is y x cos theta or not? Correct? We have seen this.
Yes.
So y is
has
equal
to
be
on
equal to
X.
1. Yes, y has to be equal to 1. Do you agree? The norm of y. Because it's y is constrained to be on the norm wall, right? Yes or no? Y is constrained to be on the norm wall. Whatever else you have said, Shoptoshi, is correct. So it will be x cos theta, right? So when will it be maximized? At theta equal to 0 degree, right? Which will be nothing but the clear or not. So it will be maximized when it will be, this will be y. So it will be maximum at y max is equal to x by norm x. Yes or no? This is all Euclidean.
Yes.
Nice, right? So this will be just the scaled version of x that will give me the y. Now is the real trick. So that's why I've kept so much space for it. That is the question number 1. Once you see the geometry of question number 1, the dual norms will be like a cakewalk. So I say x1 of dual is equal to x infinity. How will I prove this? Using a 2D case. Use 2D case. Tell me. So first, recall what would be your dual norm of x1. It will be max of some y equal to 1, the one norm being 1, and y Hermitian x. Yes or no? I'm writing this 100 times so that you are not having any problem. Is this okay? Good. So now tell me, what is the set over which I want to optimize? Do you see? So please attend the next session as well. We'll be seeing optimization in details. And then last session will only be 1 hour. So only 2 sessions are left, around 3.5 hours of class. So next day we'll be showing, I'll show you all Lagrangian operations and everything, which is very important to learn SBMs and all. But please be there. So that's why I want you to understand what this set of optimization is. So what is the set over which you're optimizing? Do you see that the one norm has to be equal to 1? Right? This is the set over which you're optimizing. So one norm being equal to 1 means what? What norm ball is it? Draw it. I've already discussed. It's the L1 norm, right? So this is
It will be like a rhombus.
exactly not rhombus, it's a square, right? Rhombus, every square is a rhombus also.
Yes.
It will be square only because the degree angle will be 90 degrees. Yes or no? This is your optimization set. Do you agree? On this, you have norm is equal to 1. Do you see the problem now? Why can't you use this thing directly? Because it's no more, your vectors are no more Euclideanly equal to 1. They are going to change in length. Yes or no? In the Euclidean space. In the Euclidean space, they are going to change its length. Here it is 1. Here it is 1. But somewhere here, what will it be? It will be half square plus half square, which will be around 1 by 2, right? 1 by 4, 1 by root 2, right? So your length vector is going to change or not? The length vector on this is going to change. Let's see. I will draw the outer square as well to make you understand. Right? Now tell me, if I have a vector x, I will show you two cases. One is you would suspect that this is going to be a, let's take it closer to y in this case for drawing reasons. You would suspect two of the, I will take you two options. One will be this, where length is minimum. Do you agree? Length is minimum. Length of y2 is minimum. Whereas this is length of y2 is maximum. But you are getting compensated by theta, right? So let's say this is some angle theta, right? Do you agree? So let us take the angle between them. So first tell me, if I will draw this again clearly. I'm just doing geometry. I'm not doing any algebra or anything. Please follow. If you don't, please tell me. So this is your x. This is y1, say, and say this is your y2, right? This is your theta. So can you tell me what will be y transpose x? This will be equal to, use your school definition. So rather y1 transpose x. Sorry.
y1x.
Y1 transpose x will be norm of y into norm of x. Yes or no?
Yes.
By your normal Cauchy-Schwarz identity into cos theta. But here cos is 0 degree. Yes or no? Dot product is defined by this way, right? This is your dot product. Yes or no? Your x dot y is given by
Yeah.
x y cos theta. And it is defined on the Euclidean space. Always remember dot product is defined on the Euclidean space. But your norm here is a not an Euclidean norm. It's a L1 norm. So that is creating all the problem. Do you see this is not equal to 1? Right? The distance from the origin is not equal to 1, isn't it? You will only have distance equal to 1. Where? Along this circle. Right or wrong?
Yes.
So you have a problem of length being different. Now you tell me why am I taking y2? Can you tell me? Can you give me the intuition? Why am I not taking all the vectors in between? Because y2 has the maximum length, right? Yes or no? You can also take and see, but y2 has the maximum length. So y2, do you agree? Y2 transpose x is going to be, this is one of the interpretation I came up with. So it is very helpful. At least many people I have shown this, they have all told it's very helpful. That's why I'm telling you as well. Cos theta, yes or no? And now do you see this is equal to 1? Correct?
Yes.
So this is going to be x, the norm of x cos theta. So we have found one of the dot products. This is found. But we don't know the length of this. Do you agree? We have to find the length of this to complete the proof, to compare which is greater, this one or this one. We have to end of the day, we have to compare what? Y transpose X and Y2 transpose X. Which one is greater? Max of these two will take, right? We'll take the max of these two by the definition of the norm, right?
Yes.
Okay. So what is, how will I find this vector's length? So I have a triangle Y and I have another triangle like this. This is theta. This is how many degrees? 45 degree, right? Yes or no?
Yes.
This is 45 degrees. So this is 135 minus theta, right? This is your 1. This is this mod you want to find, right? Correct? I'm drawing
Yes.
this rectangular triangle over here. So what will I use? Give me an intelligent answer. Let me see. What can I use to find y in just 1 second?
The cosine law.
Yes, sine law is even easier, right? Sine law will be even easier. So 1 by sine 135 minus theta will be equal to the length of y1 by sine 45. Do you agree?
Yes.
This and equal to this. Good. So you see, do you get the value for the norm of the length of y1, which is sine 45 degree by cos of 45 minus theta? Yes or no? Is it okay? See, I'm not this. I'm the only reason I skipped this step is because I thought that you know geometry of class 9, 10, 11, 12. Right? 90 plus. So sine of 90 plus theta is equal to cos theta. Yes or no? Good.
Yes.
So now what will I do? Can you tell me? So I have got this length and this length both, right? So my y1 transpose x is nothing but x2 into sine 45 degree by cos of 45 minus theta, right? Similarly, your y2x is equal to x2 cos theta, right? So what would be
Yes.
term 1 by term 2? Term 1 by term 2 would be sine 45 degree by cos theta into cos 45 minus theta. Yes or no?
Yes.
I'm just dividing these two. Good. So now how can I expand this? I'll put 2 on both sides on the top. So what is cos A, cos B? This numerator will be cos 45 also. Cos 45 is also equal to sine 45. We all know that. So what is cos A, cos B? Just recall. Cos A plus cos B is equal to cos A, cos B minus sine A, sine B. Similarly, cos A minus B is equal to cos A, cos B minus plus sine A, sine B. Right? So 2 cos A, cos B will be sum of these two. Agreed? Cos
Yes.
45 plus cos of 45 minus 2 theta, where theta is less than 45 degree. I have already taken. Yeah, I have taken theta to be less than 45 degree. Okay. Now tell me, can you infer something from seeing this equation? Do you see cos 45 minus 2 theta is greater than cos 45? Yes or no? Cos theta is a
Yes.
decreasing function. So you are subtracting
Yes.
something from 45 degree, it will be always more. So your denominator is more, right? So your denominator is greater than 2 into cos 45 degree, right? So what can you say? T1 by T2 will be less than 1, or T1 will be less than T2. Agreed? So I was just doing some geometry, fun geometry. Understood?
Yes.
So do you see that this choice is the best choice? So my norm would be, so my dual norm would turn out to be which one? X2 cos theta. Or what will you get? Which is also equal to the, do you see this is also equal to the maximum of the two components? I'm selecting the maximum of the two components. So this was close to your y1 comma y2, y1. Again, I'm mixing up y's. Forgive me for that. So z1, say z1, z2. Z1 was less than Z2, and you ended up picking up which one? You ended up picking Z2, right?
Yes.
So is it not the infinity norm of X, where we end up picking the maximum? So we ended up picking maximum of X1, X2, right? I hope this is
Yes. Yes.
clear. Good. So your term T1 and term T2. So I ended up picking which one? Just 1 second. So I ended up having which number? So T2, which is T2? T2 is this term, right? This term. So I ended up projecting X to the largest component. It is clear, right? Which is also equal to the first norm, which will be equal to the same thing that we have done. Good. Next is what is known as a generalized Cauchy-Schwarz inequality. Well, this is very trivial. Once you have understood this, yeah, it will be just one-liner. So can you tell me how to prove this? So we have seen Cauchy-Schwarz inequality as right, and we have also seen Holder's inequality, which I said I will do tomorrow, or not tomorrow, on next day, Saturday probably. Like this, right? So we are going to say that if you have a pre-norm, we can write X and Y in terms of the norm and its dual. So how will you prove that? Any idea? So again, how am I defining F dual? F dual of Y is defined as, so in this case, I've written X with dual. So F dual of X is defined as, please tell me. I've told you to find it 10 times. Max of, we already showed the maths. We showed the geometry also.
So
Max
fx
of,
equal to 1.
correct, fx or fy?
Fy equal to 1. And
Y.
y Hermitian x.
Yes. So what did I tell you? What did we do in the previous question? We picked the y that was the maximum, right? We ended up picking the y that was the maximum, and when we took the dot product, right, we picked, for this case, what did I pick?
Y2.
Y equal to, I picked as 1, 0, yes or no? Or 0, 1, whatever. 0, 1. Because x2 was greater than x1, right? Right.
Yes.
Then
Yes.
I took the dot product. I took 0 into x1 into 1 into x2. So you ended up getting the maximum, right? So you are going to optimize for the y and then put it back and get the maximum value. That's the idea, right? Now it's clear, right? Has everything become a circle? That's what I want to ask. So what can I write this as? I have already told you not equal to 0. Y Hermitian x by fy into x. Can I write this? Already shown.
Yes.
Because your f of y by fy is equal to 1. So I can write this, no problem. In the earth, whatsoever in this earth, I can write this. So do you agree? This is again, I'm going to use max is greater than equal to y Hermitian x. Use this throughout your norms, you will get all the answers. Done? Agreed? So you will end up with y Hermitian x is less than equal to f dual of x into f of y, just by cross multiplication. Yes or no? 2 lines proof, right? Any doubt? So before we go on to prove that general LP norms, that was the goal of today. And the last thing on vector norms before we move on to matrix norms, which will be like 15 minutes long, because I'll not teach you because that's a huge subject in itself, because it's not, you need to have a proper matrix theory course to have that. Not seeing enough interest, so I'll give you only a little bit of the matrix norms. So okay, so in this case, is it clear that you can multiply the dual of one norm with the primal norm of 1 and it will be greater than equal to the inner product? Is it okay? And let's see how is it useful. It is useful because the dual of a dual is equal to the primal norm if f is a norm. Pre-norm, it will not work, but if it is a norm, it is going to work. I'll show you one part of it. The second part you can omit for the time being because it's a technical proof and you need a little bit more of background to it to know it. But once you are able to understand everything, you can look it up in Horn and Johnson. But I don't think you'll be able to understand it yet. At least it will require half an hour to explain that. So I'll omit that. So first I will prove the dual norm of y is less than equal to the primal norm. Dual of the dual is less than primal. So my end goal is this. If f is a norm, the dual of the dual is equal to f. So there is a 1-1 corresponding. You take a dual, you get f dual. You take a dual, double dual, you're going to get back f. If and only if f is a norm. But we don't will. So let's prove one side of it, that f dual is less than equal to the primal norm. How can I prove it? If you understood first step, what will I write? Dual of the dual, how can I write? So f dual of y, can I write it as max of f dual of x equal to 1 y Hermitian x? Yes or no? Because I'm taking the dual of this norm. Correct? Whatever dual you are going to take, put that in the constraint, right? That's what we saw in the picture. We wanted to take the dual of the square norm and we ended up getting a like invert tilted square norm and we ended up getting a straight square, right?
Yes.
So from how can you prove this now? So can you use the generalized Cauchy-Schwarz to do this? So what will the generalized Cauchy-Schwarz give me? F dual of x.
Dual of x and fy.
Correct. Max of. So I'm replacing it by that. So this is equal to 1 from the constraint itself, right?
Yes.
So this will be turning out to be f of y. So which part did I omit? I have to also show direction 2. So direction 2 I have to show is, if it is a norm, I have to show f is less than equal to f double dual. So this is technical. This is if and only if f is a norm. Right? If and only if f is a norm, this will happen. So do you agree if I can show this to, so this is a known, you know it for a fact. If you want, if you're interested, you can write it in the Teams group. I will give you the solution there. It's not possible to prove it now. Otherwise, we'll miss the important parts. So if I link direction 2 and direction 1, what will I get? A less than equal to B and B less than equal to 1. B less than equal to A means A equal to B, right? So your F is equal to F dual dual if and only if F is a norm. Okay. So this I would be giving you as a homework, but I have the hint already given here. So I will give you the understanding of how to do it, and then you can do it as a homework in the assignment. So, but I'll be telling you how to do it. It's a very simple proof, but that's why I'm going to give you 5 marks for it. But I'll give you, yeah. So this is what will I do? This, but I will show you the general procedure to do it because it will help us in the matrix norms. Right? So we will define, so this Holder's inequality we have already seen, right? Such that 1 by P plus 1 by Q is equal to 1. Yes or no? We have already seen this.
Hi.
We have to show that the dual norm of the P norm is the Q norm. So your entire space is linked. So did we see that the x2 norm, did you find it a coincidence? Didn't you see x2's dual was equal to x2? Right? So you had this is equal to P, this is equal to Q. So 1 by 2 plus 1 by 2 equal to 1, right? Was valid. Similarly, x infinity dual norm was equal to x1 and x1 dual norm. So I have told you dual is equal to the dual. So I can take dual again on both sides. What will I get? So, right? See, everything is getting into a complete cycle, isn't it? So you're using each and everything properly. The complete picture is coming up. So here you see P, this is equal to Q. So do you see that 1 by P plus 1 by Q, which is equal to 1 by 1 plus 1 by infinity is equal to 1, right?
Yes.
So it will be true for any PQ. And I'll show you why. I'll show you the steps, but the calculation you will do, then only you will understand. I want you to get this 5 marks, so I'll show you the steps as well. So I have shown you, if I can show that XP dual is less than. So from the Holder's inequality, I can show something. Can you tell me what I can show? So Y Hermitian X is given to be less than XP into YQ. What can I show you from this? I can show one direction of the proof. So if I have to show equality, when you can't think of anything, try to show both inequalities, right? Try to show this inequality also and this inequality also. From this, what inequality can I show? This has to be your step 1 or direction 1. What can I do? So can I divide this by P? Do you agree? Since this is a positive number, is this okay? Oh, it's not arrived, but it will come. Yes, right? Yes or no?
Yes.
So now is the right hand side independent of x? Is independent of x, right?
Yes.
So why it will be true for all x? So I can take the max over the left hand side, right? So what is this norm? Dual norm, and I have shown that that is equal to the Q norm? Yes or no?
Yes.
This is trivial. And tell me for the second part, if I will not do this part totally, but I'll show you, give you the hint since it's assignment question. Step 2 is your xi is equal to. So I will give you the hint. I have already given you what you need to take to show that. So do you see that your yp, or rather yp dual, is defined as max of yes or no? It's defined this way.
Yes.
So if I can get a particular x, and I have given you the particular x here. Just check. I've given you terms of q. You can do it in terms of p as well. No problem. If I can get a particular x such that y Hermitian x is equal to yq, will I be done or not? If I can get if I get a particular x such that xp is equal to 1 and y Hermitian x is equal to more yq, am I done or not? This is a particular x. So this will be always less than equal to the maximum of all x's. Yes or no?
Yes.
So if I can get a particular x such that I can make y Hermitian x is equal to yq, then can I say y dual of p is greater than equal to yq, right? 1 and 2. So 1 plus 2 will give me y dual of p is equal to y do q. Or if you can, since it's a norm, you can take dual on both sides. So it's symmetric, right? Right? Is this clear? And I will tell you which step you need to do in your homework. Is the overall goal to solve the question
Can you
clear?
repeat the step 2 once?
This statement you're saying.
Step 2.
Yeah. So I'm saying I have this as the definition, right?
Yes.
Don't mute yourself. I'll give you the cues, you respond accordingly. So if I have a y such that y Hermitian x is equal to yq, right? Right? I will be
Yes.
building that particular y, or not y, man. Y have I written? Particular x, right? Because I'm optimizing over x, right? If I have
Yes.
a particular x such that y Hermitian x is equal to yq norm, which is what q norm is? Y1 to the power q to the power 1 by q, right? I equal to 1 to n, right? If I can show, I can build one norm like this. If I can get a x like this, so will that be a lower bound on this? Because I'm taking a particular case of this function which I'm optimizing to get the maximum. So that particular case has to be less than or maximum it can be equal to, right?
Yes.
That's the question. So what x will I choose? You will choose this x. So I've already shown you, if you multiply and use 1 by p, use 1 by p plus 1 by q equal to 1, you will be seeing xi is equal to the q norm in this case is equal to 1, right? And you will be also seeing that x transpose y or x Hermitian y is equal to yp. Let me just check this is true. Y. Yes, correct. right? So use this particular exercise and that will do it for you. Is it clear? This I've given you the particular exercise that you need to choose. Is it okay?
Yes.
If you want me, I can show you why is it true, but because your x Hermitian y is what? Your y Hermitian x, it's just nothing but y bar this, right? Isn't it? This is what your y Hermitian x is, right? Isn't it? Correct? Is it okay? So I've given you the x, try to put the value of x and show that the q norm is indeed equal to your q norm is indeed equal to 1 and use it to show that the dual norm this for this particular x xi or particular x particular indeed turns out to be this. So then you will be done. Okay. So we are able to show that this is equal to. So we have come to the last part of the linear algebra course where we'll be describing. So all this while, what have we discussed? We have discussed energy in vectors, right? Yes or no? Now what we'll be doing? So we'll be describing energy in matrices. So we'll be describing the energy in a matrix. And
Is energy here?
energy is, well, how do you define energy in a Fourier series? You take the sum of the squares, right? So if I'm trying to sort of get that motivation. So where it's all sort of total, what is the amount of determinant present or eigenvalues present, or what, how powerful is the matrix, how large are the numbers, and so on, right? Will be as you go on, you will see why it is useful, right? There's very few things that you need to see. So you see, so we have seen a power of a vector was defined as this was a norm of a vector, right? Had positivity plus what else did it have? Homogeneity plus triangle inequality. A matrix norm has all these properties. Plus, it also has what is called a multiplicativity. Multiplicativity. Why is it essential? This is because we want to bound the energy in the a to the power k matrix, right? We have already discussed that a to the power k using eigenvalues. We can find the eigenvalues and then do a to the power k. But we also want to bound this energy in terms of the norm of a. This is the intuition. So if you want a norm to exist, we want the norm of the matrix to follow this. What does it mean? If you may ask, it means the product of the two matrices will be the norm of the individuals, right? Is it clear? So what are the four properties? Right? It will have positivity, homogeneity, triangle inequality, and submultiplication.
Matrix norms.
Yeah, go ahead.
So all vector norms can be considered matrix norm.
Exactly. I was coming to exactly this question. Exactly. Very good. I'm very happy. Finally, one of the students is thinking properly. Very good. So let us prove some properties of matrix norms and then I will come to that question. Okay. Is it okay if I do that way?
Of course.
Okay. So some properties I'll prove is, I already told you this intuition. These two properties let me prove. Rather, let me prove all these three properties and then I'll come to Frobenius norms and show you. Okay. So let's prove this property. So first property I'll be proving is a to the power k, the norm of this is less than equal to this. How will I prove this? Can you tell me? What will I use? Of course, A has to be a square matrix over here. What will I use?
We need to multiply it.
Correct. Right? So again, using submultiplicativity, I will get, right? And then by induction, I will get, right? I will keep on decreasing this. So you are done. Second proof, how will I prove? Second one is also trivial. There's nothing much. See, for this is becoming true for any of the matrix norms. So this is the beauty of abstract maths. So you don't need to define numbers and even algebra and equations as such. You can define classes and operate on classes themselves. So any norm would have this property. Do you agree? A inverse A is equal to identity. This is by definition. So and then this is greater than equal to by submultiplicativity A inverse A, right? So what will I get? A inverse is greater than equal to identity by A, right? Good. Now tell me the third property. How do I prove it? You can prove it, I know. This is very simple. For idempotent matrices, what will happen? So we have seen idempotent matrices. Hussein, do you remember? Brahmuji, do you remember? That I had said projection matrices were equal to P, right? So once you project onto the plane, you can't further project, right? If you have a matrix that projects to a plane, it is done. Once you get a vector, you will be staying there, right? Yes or no? We had seen the projection matrices in linear regression and so on. Good. So for idempotent matrices or projection matrices, you have A square equal to A. So how can I prove for idempotent matrices the energy would be greater than 1 or the norm would be greater than 1? What will I write? A square as yes or no? Are you able to use the properties? And this is also equal to A, right? As I square is given to be A. So you can cancel this and this. So you have, right? Good. And now coming to your question of whether all vector norms are matrix norms. So I have taken a special case where I'll show that your vector norm is indeed a matrix norm, but it need not always hold. I'll give you an example as well. And I'll tell you to maybe I'll not give it as an assignment. It's a bit tough. Maybe if you are interested, please refer to that on the chat. I will give you an exact example where it is not true and I'll post it, right? But I will show you an example here where it is going to be a matrix norm. So we name this a Frobenius norm. Your machine learning uses this all the time. So Frobenius norms are used to normalize in machine learning always. You divide by the square of all the elements, right? So say you have a matrix A. So So if I have a matrix A, a Frobenius norm. So this is also called a induced, non-induced, or a vector norm on a matrix. So this is not a special matrix norm, but a vector norm, right? So this is defined as summation of ij square to the power half. Is this same as a vector norm? Saptarshi, you were telling, so vector norms will be, right?
Yes, yes.
So this is same as the, if I stack the elements A11 till ANN, so this is same as the L2 norm. Now, so your positivity will be holding, right? Homogeneity will hold. We have already shown this property, then triangle inequality will hold, right? As it is a vector norm. Agreed? Which one have we not shown? We have not shown
Submultiplicity.
submultiplicity. How will I show it? Any idea? So I will start off with AB, right? Always, linear algebra is very simple. You can always start off with the definition and continue. So the two norm, I'm not going to put three norms. Three I will put a bit later than last topic of today. It's the second last anyways. So this is, do you see that this is equal to AB II squared summation of I comma j to the power half, right? The product of, so I have A and I have B, I multiply them to get C, which is nothing but equal to AB, and I am taking the squares of each element, right? This is the definition, no problem. Yes or no?
Yes.
So what is ABIJ? Can you tell me in terms of the sum of A and B? Say A is a M cross N matrix and B is a N cross P matrix. So what will the sum be to get the ijth component?
I equal to 1 to n.
Don't use I, use, because ij I'm already using, use k. K equal to 1 to n.
Then matrix A
Okay,
will be
A. Which component, which element will I take to get the ijth element in this? The ith row, we have seen this interpretation, right? Ith row and j. Yes, ith row and j. Yes, very good. That shows you have at least studied. Good. So now what will be the square of this? Square? Yes or no?
yes.
What? Now triangle inequality I can use again.
Yes.
A plus b whole square, triangle inequality is less than equal to a square plus b square. So you will be left with what? K equal to 1 to n. A ik square and b kj square, right? Right?
Yes, yes.
And then I can sum. So my desire is to sum this over ij, right? So if I sum this over ij, can I do something like this? This you will tell me if I'm allowed to do. I comma k and if I'm allowed, y I'm allowed to do. And j comma l. Tell me. So this proves this line is left. Why is it true? So if we can say that, we can separate these two sums. So there was no L, right? There was only I, J, and K, right? And we have individual sums. Do you agree? As products.
Yes.
So if I
Yes.
introduce a L as well, L equal to, say, from 1 to P. So do you agree this will again be an upper bound or not? L equal to 1 to P. So I will be having more terms, right? So this already has these terms, and it will also have already has the terms above plus terms related to P. Correct or wrong? Right?
Can you explain more?
So you see, so this is Ik and Ij. So you have two sums, right? So your all these terms that are present over here, are they present here? If I expand this, will I get or not?
Yes.
You will get, right? Say you fix L to be K, or in our case, right, we are fixing L to be J. If we fix it to be J and J to be L to be K, will we not have all the terms? We will have, right? But we will also now, since we have introduced this term L, we will also be having more terms, which will be P into Ij and so on. Do you
Why
agree?
the less than equal to sign will come?
Yes, it will become even more. So this will be
Okay.
LHS plus some more positive terms. So greater than equal to sum will come. Already greater than sum equal to was there due to triangle inequality, or making it more greater. No problem. If you want to make greater things greater, no problem. Lesser things lesser, no problem in maths. Opposite signs are not allowed. So as you were asking, so similarly, A1 can be is a valid norm. You can check. But A infinity is not. It's not a valid matrix norm. So try this as a homework. Try to post it on the Teams. If you post it, I will give you the solution. Even if you mention how to do this, some ideas, I will give you the entire solution. I promise. But I need a little bit of proactiveness from you. If you give me that, I'll show you. So the maximum element in a matrix need not be a matrix norm. It is a norm induced on a matrix. Norm induced on a matrix, all right. That means it is a vector norm only. Good. So that ends. So we have shown Frobenius norm. The last thing, which is known as, I have just kept one example. This is one of the most important things you would encounter if you are dealing with signal processing, where you would be seeing norms being induced on a vector, right? So we have recall. It will take only 5 more minutes, so please bear with me. And this will give you the entire full feel good factor, because this has the ingredients in it too. This will, so I think my screen is locked, and is my voice audible?
Yes.
This will link matrix. Let me just click on the screen. View. Cancel it. Okay. Just 1 minute. I think it got disconnected. That's why. Yeah, you can see the screen now, right?
Yes, sir.
Okay. So
Yes.
we will. Yes, yes. Okay. So recall that we have done what is called a vector norm. And now we'll be linking matrix norm with a vector norm. So these are called induced matrix norms. Now, why is this important? This is because what is AX? All of you who has done my last 3 sessions will be able to understand what is AX. Can you tell me? I'll give you the intuition that no one can give probably. What is AX? A vector in the column space, right? Right or wrong? So A is
Yes.
A1 through AN. So AX is alpha, say XI, AI, where AIs are the vectors. This is why I taught you to treat a vector matrix product, linear combination of the columns. So a matrix norm can be defined as the maximum energy that any unit norm can induce from a matrix. Is this clear? See, it's defined as the maximum norm, maximum energy, maximum length or energy a unit norm can extract from a matrix in its column space. Is it okay? Isn't it? AX are AX all the, so AX are all column space norms, right? Column space vectors, right? And I'm saying for a unit vector, what is the maximum amount of length you can get from the matrix? Is it clear? Is the intuition clear? So for that norm, it is called the induced matrix norm for that particular norm. Good. So there are a few special case, and that will give you an entire understanding of the flavor of induced norms. And given do, if you are interested, they will connect eigenvalues with matrix norms. See. So prove that for induced matrix norms, I'll be providing with 3 brackets for 3 lines for 2, because I'll be using a norm, 2 lines to induce the norm. The matrix will be with 3 lines. This is the convention. With 2 lines, it will be a norm on a vector space. Same vector norms applied to a matrix norm. So can you tell me why is it equal to 1? For any, this is the beauty of the induced norm. For any induced norm, your identity will have a 1 as the energy it can extract. Why? Tell me. So what is I by definition? Start from the definition. Max of, yeah, tell me.
Single one. Huh?
Max, yeah. This one you're saying. You said this, right? So by definition, it is 1. So this is equal to 1. This is done. The second one, how will I do? Can you tell me? AY less than equal to the norm of Y. into this. This is also simple. This first one was very simple. This is a bit involved. So AY, what have we defined? Yes or no? Correct? I'm going to take the maximum, maximum space, maximum energy. So if I write max of Y not equal to 0, I have been doing this all around and scaling Y, right? So this will have Y by mod Y has a norm of 1. Do you agree? So I can put any Y now, right?
Yes.
So what will this be? So your max will be always greater than, right? So again, that same trick I'm going to use for any Y. This norm will be what? Less than the max. Yes or no? Which is equal to the matrix norm. So it has a wonderful property that if you have a matrix vector product, this is less than equal to sort of a vector matrix submultiplicativity, isn't it? Vector matrix submultiplicativity. Agreed?
Yes.
So final thing that I'll do is, this is the last thing, and I have put down 2 reading that you can do to show that the A infinity norm is the row sum, and spectral norm is the maximum eigenvalue. These 2 things I will show, right? These things you will to read. I'm just going to show you one example where the induced L1 norm of a matrix is the maximum column sum. Any idea how will I do it? Induced,
Can you repeat?
induced matrix norms. I'm telling you the sentence. Induced matrix norm is the maximum column sum of a matrix. So what do I mean by a maximum column sum? So if you have C1, C2 dot Cn as your C matrix, so your C norm will be max over the L1 norms of the columns. Is it clear? This is what I want to prove. Over all the i's. So you say you have this you sum to S1, S2, S3, Sn. If you sum all of these, again my tab has stopped. Please bear with me. Sn. So if you have all of these 3 Sn, so you will select the maximum of S1 to Sn. Agreed? Good.
Yes.
Okay. So how do I prove it? It is not. So I have to use this definition, right? Max of is equal to 1 AX. Do you agree? I have to use this definition to prove. Right? So again, I will be proving less than equal to and greater than equal to. So which one do you think is easier to do? Can you guide me in any of these? So I'll be showing that this is less than equal to the maximum of column sum, and then I will be showing the maximum column sum is less than equal to this norm. Can you tell me how do I do it? Okay, let's do it. So AX, what is it? Do you agree that it is equal to AI XI? Let's write A only so that there is no confusion at all. Right? It's AI XI or not? AX is where XI is as a
Yes.
skill. And right? So this is a vector, and you are going to take the L1 norm, A1 X1, the sum is a vector, right? Because this is a linear combination of the AIs. So good. So what will I use now? Triangle inequality, right? I can use triangle inequality or not?
Yes.
So if I use triangle inequality, so direction 1 I'm showing. So I will give you the row sum as the assignment question because this is the same process. 2 assignment questions are already decided, but this spectral norm, if you are interested, please read. It's very interesting. Okay. I equal to 1 to n. Right or wrong? Correct? Triangle inequality.
Yes.
I have just used x plus y1 is less than equal to x1 plus y1. I hope you understand after the entire 2.5 hours, almost reaching 3. Okay, so if I replace AI, okay, the norm, this is, do you agree this is the sum of the columns? Sum of columns?
Yes.
Because this is the L1 norm of this, L1 norm of this, and so on, right? Would be, isn't it? L1 norms are the sum of the columns. Okay, so if I put an upper bound, if I put a max of I or j between 1 to n, summation of I equal to 1 to n aij. Is this okay? Right or wrong? Put m, no problem. M by n matrix will do as well. A is our m by n. Right? Is this okay? I'll show you again, no problem. If you are not okay with this, I'll just show you. So do you see that you have all this AIs, right? The one norm of the AIs, correct? I'm giving you the cues. So if I replace each of them by the maximum of AI, do you see I will get a strict inequality? Right or wrong?
Yes. Yes. Yes.
These are all positive numbers. I'm going to replace all of them by the maximum of them, and which is a constant, which I can pull outside. So what is this? Mod of xi? Is it equal to 1? From the definition of inducing the norms? Right? So you got max of, or your one thing you got is less than equal to max of 1 to n sorry for that, max of 1 to n I equal to 1 to m aij, right? This we have shown, right? The last part would be to show this side, right? Correct? Yes or no? Direction 2. How will I show direction 2? Let's take x as 0, 0, 0. Very easy. 1, 0, 0. Do you agree mod x of 1 is equal to? So for the direction 2 always has to be a particular solution. This is why I want to instill in you. This is the way you prove it. And so on, right? This is the maximum column. I know the column which is maximum from beforehand. I'm putting 1 there and 0 all. So do you agree that the mod x is equal to 1? Yes or no?
Yes.
There is only 1 and all zeros. So your x, what is this? Ax is nothing but your column A max, right? Because I'm only having 1 corresponding to the A max and others are all 0, right? Yes or no?
Yes. Yes.
Which is equal to max of Aij. So do you see that this is less than equal to max of mod x equal to 1, Ax, which is equal to norm of A. Have I shown both the direction?
Yes. So
1
will the
plus,
summation be the second
yeah,
summation
this second summation,
I equal to 1 to n or m?
m, sorry, very good. So you're following, very good. So 1 to n is showing that your norm, L1 norm, is the max of good. Proved. So try to prove. This will give your assignment 2 will be out tomorrow. Please submit it. I will tell ma'am to give you a certificate on completing the course. Tell everybody who has enrolled 10% was on the attendance. If they see all the videos now on YouTube, it's shared and they give the assignments, which is 90% of the course, you will get, if you get more than 70%, you will get a certificate that you have completed the course. Otherwise, how will I give you the certificate? Two things I can do. I can see 8-9 people have done classes regularly. So I'll stop the recording here and I'll tell you the logistics. Yeah, 8-9 people have done